In general, the superposition principle is that two things can be in the same position at the same time. Not everything can superimpose, but waves can. So what the superposition principle is that two or more waves can occupy the same place in a medium. This works because waves are not physical objects. Waves are disturbances in the medium. And so the medium can have two disturbances at the same time. Sorry about that. The medium can have two disturbances at the same time. The amplitude when we have superimposed waves is the sum of the wave. We just add them together. So we're going to draw the resulting wave when these two pulses occupy the same space and then immediately after. This occupying the same space, that's the superposition. So yeah, here's what we're going to do. We're going to make a little table. We're going to have a during superposition and after superposition. This is wave interference, right? They're gonna be in the same position. They're gonna move off, and they're not gonna affect each other. So when these two waves are in the same place at the same time, what we get is an increase in amplitude because we're having A and A adding together to give me 2A, and then afterwards they move on with the same amplitude A that they had. They don't bounce off of each other, they move through each other. The second one, we got an up and a down, so when they're in the same position at the same time, the amplitude is 0. You have plus amplitude, negative amplitude. You add those two things together, and you get 0 amplitude. And then after this, the two waves move apart, having not disturbed each other. So the negative one is still moving to the left, and the positive amplitude is still moving to the right. For this one, you have 2A and A. When they're in the same place, we add them together. So that gives me, that gives me 3A. And again, they move on undisturbed. So your 2A wave is still moving this way, and your A wave is moving in the same direction it was before. And so for part D, you have 2A plus 2A and then negative A. When they're in the same place, we get an amplitude of A. That's what happens when you add 2 and negative 1. And then they move on past and through each other as if they didn't meet. Because, again, waves are not physical objects. Waves are disturbances in the medium. And so these two disturbances in the medium can pass through one another. This is why when you're talking to someone and they're talking at the same time that you are, of course, if that's happening, you might be yelling. The waves pass through the same place in the air at the same time, and then they move on. That's how your words make it to someone else. They don't reflect off of their words. They pass through one another. When do waves interfere destructively? Destructive interference is when you have an in-phase, I'm sorry, I spelled phase wrong, an in-phase wave plus an out-of-phase wave, or a crest plus a trough. When those two things, when you have a positive amplitude and a negative amplitude add, you have destructive interference, and then constructive interference is two in-phase waves. Destructive interference is active noise canceling. So your earbuds have a microphone on the outside. They detect sound waves coming in from the outside world, and they send. So if here's the, I love how this works. If that's the incoming wave, what they'll do is send a wave that's the exact same size and shape, but it's just bent out of phase, and when those two things interact, you get nothing. That's active noise cancellation. The active part is that your headphone is listening and producing that wave. All right. Describe how a standing wave is formed through interference. Okay, so let's say this is one wave. You have one wave moving in this direction. And then you're going to get an identical wave. It has to be identical, moving through the medium in the opposite direction. I can do this, you can't. So this wave, as they're moving through each other, here you have two crests. That's constructive interference. Then it moves again, you get destructive interference. So that's a flat spot. And then they're lining up perfectly. That's constructive interference. Then we get destructive interference, then constructive, then destructive. And so in order to get a standing wave, two identical waves pass through each other. And here's what's important. They're identical. The standing wave is a repeating pattern of constructive, then destructive, then constructive interference. Over and over and over again. Draw a standing wave with 2 nodes and 3 antinodes. All right. All right, so we'll do one part of the wave now. I don't think that's quite possible. Here's the other part of the wave. Here's the sort of reflection. It's only doing the black at any given time. Right. And then this is what it would be for the flat part. So that's what we draw when we draw a standing wave. So it's going to go up, then it's flat, and then it's down. This area here, that whole thing is called an antinode. That's an antinode. That whole space is an antinode. It's the place where we're moving the most. And then these guys right here are the nodes. Nodes are areas of least movement. Antinodes are areas of most movement. Draw a standing wave with 3 nodes and 2 antinodes. All right. Okay, so this is going to be 1. This is going to be the other part of it. And then this would be the flat part of it. These here, oops, sorry, missed. These here are my antinodes. And these places are my nodes. How does a guitar player control the frequency of the standing wave produced in his guitar strings? So different strings have different speeds. So plucking a different string is going to give you a different frequency. That's the first one. Changing the length of the string changes the resonant frequency that's possible, and then changing the tightness. So it's changing the tension, changes the frequency. When do waves interfere with each other? Waves only interfere when they are in the same medium at the same time, in the same place. What kind of waves interfere to produce standing waves? For standing waves, what's really important is that we have identical waves. They have to have the same frequency. They have to have the same amplitude. Otherwise, we don't get the cancellation and then the big amplitude that comes after it.